Welcome to this video that's going to take you through the technique known as EPS within MRDCL. EPS stands for Excel Productivity Scripting, and the key word in that name is productivity, because that's exactly what this technique gives you. It gives you ways of templating commonly used or perhaps complex procedures that you want to invoke using MRDCL. The one we're going to look at here is just an example, and we'll go on to other examples later, is how you can use it with a rating scale. Now, most questionnaires in market research have a rating scale, so this will be quite familiar to most people. And let's look at this template and then see what it means and how we can apply it and how we could even adapt it for other scenarios. So the template we're looking at now is called My Workbook.xlsx, and in it we've got definitions for 3 rating scales: question 1, question 2, question 3. Here's the text for each one. So this one here's the rating of brands, this is rating of some new brands, and question 3 is whether they're healthy or not. In here we specify where that data is located in our data file. So the first question starts at data location 11, the second one at 21, and so on. And then this tells the template how it steps up from rating statement to rating statement. So the first rating statement is going to be in 11 for question 1, the second one in 12, the third one in 13, and so on. We could have 2 in here, and that would mean that for question 2 it would start in 21 and then go to 23, 25, etc. This one here gives me the list of things that are in each rating scale. So we can see that question 1 and question 3 share the same list, and question 2 has list 2. And if we go down to the worksheet here, we'll see that list 1 picks up brands A, B, C, D, E, whereas list 2 picks up brands AA, BB down to FF. And if that list was to run to 26, it would go up to brand ZZ, and this template would automatically adjust itself to give us the tables that we want for 26 brands. The next thing that's being specified here is the text that are applicable to each of these rating statements. Now, this is a good example of showing you how you can adapt this template to do exactly what you want. This template's been programmed to understand that very good to very poor is indicated by VG-VP, and agree strongly to disagree strongly is indicated by AS-DS. And you could have any number of texts in there. So we might have another one which handles rating scales that run from 1 to 10, another one for a 7-point scale, and so on. So you could handle any types of scales in here, or they needn't be scales, they could be some other piece of text that aren't rating scales but just something else that appears within a grid. So this has been programmed to understand that VG to VP means that we got very good, quite good, neither good nor poor, quite poor, and very poor. In this column, banner, we specify what the standard banner is. That can either be just a single variable, as it is in this example, gender and age are being used, or it could be a group of different variables that you want to put together in a banner to perhaps show gender, age, region, and so on. Now comes the interesting part. This is a way of telling MRDCL what types of tables you want. Now, this example's only allowing 4 different types of tables from rating scales, but I've known clients to have nearer 20 different types of tables that they want from a rating scale, but this one's only been programmed for the 4. So the 4 here are producing a top 2 box, a top 2 box and a bottom 2 box, a summary table of mean scores, and I think summary 2 is a summary of mean scores again, but ranked in descending order. And you could extend that as far as you wanted over here with other types of tables. Maybe you wanted one with each of the rating statements side by side in 1 column each. It would just be a case of programming in those options so that then you had a template that could handle all the different types of tables that you might need. So the goal of this template is to put in all the different ways that you want to be able to handle a rating scale, so that then anybody can use it, you can share it amongst colleagues, store it on your server, and use it and reuse it from project to project as many times as there are rating scales on that project, and of course across a number of projects. So now we've got this in place, these X's here are going to indicate which types of tables I want for each rating scale. So that's all in place. I can now switch to my MRDCL run and run that. And sure enough, it goes away and produces 18 pages of output. And here's the table. So first of all, we've got a top 2 box for question 1, brand A. We scroll down and get a top 2 box for brand B, brand C, brand D and brand E, and then we get a summary of means ranked, which is showing brand E as the highest with A as the lowest. For question 2, we've got a top 2 box and a bottom 2 box for the 6 brands, and then finally and a summary table there, but not ranked this time. And then for question 3, we've got a top 2 box and a bottom 2 box for each of the 3 brands, whether you can see slightly different labels here. Agree strongly, because they were the labels that we pulled in. Now what this means is, if a researcher or wants to change, or the client wants to change what you want, you can just change this by clicking X's in here. So if we wanted a summary table added here, ranked, we could just add an X in there, and you can see we've now got a 19th table added to the end, which has a mean score rank table for question 3 as well. So it's very easy to change this. If I'd made a mistake with the labels here, and this should have been a agree strongly to disagree strongly, I could just edit that and again change it. Now how you denote all these options that you want to select is your choice. I could have just typed in the different types of tables here, saying top 2, bottom 2 as items within each of the columns. How you design it and what you do to run it really is your choice. So all that happens in the script for this is that you open the workbook at the beginning, you specify the variables you've got in the normal way for gender and age and any other questions. You insert the grids STP file, which could be on your server, because it'll be a generic script that you never touch once you've got it working, and that would read the workbook that we just saw just now, called My Workbook XLSX, and pick up all the variables. And then you can see in the tables here, we'll call another file which is insert grid tables, and that will automatically produce the tables that we want based on the X's in those columns. So we have a system where we don't actually touch any script at all. We just indicate in the spreadsheet what we want, and then it will automatically generate it for us. And that obviously really is obvious to understand that it's going to save you a lot of time. Junior staff can do a lot of this work. The script that's generated behind the scenes by MRDCL is just effectively pre-processor code that's generated for you. I didn't type any of that in. All that code there was generated by that spreadsheet and a couple of lines of code. So 266 lines of code there generated from just that short piece of script that I can use and reuse from project to project. So let's look at a couple of applications now that can also be used this way in other projects. One of the things to say first of all that might be worth giving some thought to is that you can also build little macros on top of these spreadsheets. So here's a similar example. So here, as soon as I click on a particular field, you can see these things pop up, and I can edit and change these things, or I can click on a blank column and I could put in question 5, age is my banner, and I could pick those tables. So I could make it a slightly more interactive experience if I wish to as well. So there's a sort of cut down version of what I was showing you just now. But let's look at some more practical examples and see where we can use it. I'm going to close the example I was using. So here's an example of a workbook that deals with quite a common problem, and something that people spend a lot of time doing typically if they've got a lot of long code lists. So Sometimes you get quite long code lists that have been coded by people, and there's a need to have subtotals so that subtotals are automatically calculated, they're ranked, and the codes within those subtitles are ranked within them. Now that's quite a fiddly procedure to specify, particularly if you've got long code lists and you've got several questions with open-ended questions. So let's look at how you can achieve that. So here there's a very simple system that basically somebody working in coding can adopt, that they put the codes in here that are active, they put the texts in here, and then either they or someone, perhaps a researcher even, or a person in data processing, can say what group each of those codes go into. And then down here, the ones that are nets or subtotals get denoted with an X. So this means that favourable comments with a 1 is a subtotal, and these things with a 1 here are the codes which go into that subtotal. Packaging comments of colour 2, so these ones here with the 2 will go into that subtotal. And all of this is going to be done automatically. There's going to be nothing done on anybody's part here to actually do any scripting or anything else. So let's just look at that working. So I'm just going to go to the folder where that's all stored, and in here now I can run this, and you'll see what it's doing is, you'll need to cut this out, Emily, because something has gone wrong here, so there's an edit needed. Hopefully when I run it again, no, it's not working. That really is quite annoying, so there's going to need to be quite a big cut here, but I'm going to carry on. I don't know what's happened. Okay, it's working again now, so I'm going to resume again now, going back to that workbook. No, I'm not going to resume yet. Okay, it's all working now. I'm resuming. So we've got the subtotals here all set, and if I run that now, you'll see it will make my tables. And you can see that what happens is the favourable comments comes out as the highest subtotal, so that's ranked at the top. Green box is one of the things in that subtotal, and best on market goes underneath it, because they're ranked as well. The next subtotal goes in as 2, and they're ranked in descending order as well. And now what we can see is, I think probably green box should be in the colour subtotal. So what I'm going to do is I'm just going to quit that. I'm going to change green box to be a mention of colour, which is item number 3. I'm going to just save that, and if I run that again, you'll automatically see now that packaging comments colour goes to the top of my table, because green box in fact is the one with 3 in it, which is going to change the subtotals. Now again, that's saving me absolutely hours of time if that was a big code frame. That is quite an unpleasant procedure to set up in MRDCL, where you want to set up all of the subtotals using G1B and G1P. All those codes there you've got to type in. There is no typing at all here. Everything is marked within the spreadsheet so that everything is automated. An MRDCL script is reading that standard way of handling code lists and automatically getting the subtotals and the rankings automatically done. And you can extend that one further. There's an example here that has another column called merge. So this is telling MRDCL, or this template rather, to merge code 7 into code 6. So maybe there are very low responses in code 7, so it's going to merge them into that code there. There's other examples we can have here. Here's another example where data corrections have been put in. So again, we recommend that you never physically change data. Physically changing data means that it's very hard to undo it. If someone makes a mistake, you'd have to go back to the original data, and that can take time if there's a mistake or someone's misunderstood an instruction. So again here, any data cleaning can be put into a spreadsheet. You can even record who it was done it and the date and time they did it, so that you can always undo these things. So say Betty was doing the data entry wrongly or the data corrections wrongly, we could take out all Betty's corrections and redo them. There are many other examples. Here's another example. Here's a spreadsheet that actually produces market research tables, all scripted in MRDCL. So here's a template that's been set up where someone can specify the variable, the banner that's needed, the title, whether you want to use it, whether there's a filter, whether you want to insert any MRDCL script. So there's a script behind this here called myq2.stp that will automatically get called in to do something extra, perhaps something that's too difficult to specify through a simple spreadsheet like this. Any format options can be specified here. So you can do a lot of stuff now in spreadsheets. It means that junior staff can help you, coders and researchers can do parts of the project that are relevant to them, and perhaps also quite importantly is a project becomes much more intuitive. It means that if you take over a colleague's work or someone goes sick or it leaves, it's much easier to see what they're doing rather than looking at heavy duty MRDCL script and trying to work out what they've done. Well, that completes this video for now. There will be a video coming out shortly that'll be a challenge to see how much more quickly someone can do something through EPS rather than actually scripting it. But that's in a future video. Thanks for taking part.